Welcome. On this channel, I do unedited, unscripted videos about Linux and programming. Currently, I am in the process of relearning C. It's been about 25 years since I've used it. If you go backwards through the videos, you'll see I am experimenting with malloc right now. And I realized in the previous video on the thing that I was working on that while I understand conceptually the pointer stuff, no problem, I apparently am getting tripped up on the syntax of like pointers to pointers and dereferencing them. And so this video is specifically going to be making sure that I have a concrete example of that and fully understand it. And it'll be a little easier just to dive in and show you where I'm going here. So CD projects, C stuff. So what I got going on, is I create a folder for every video. This is going to be the 19th one, so I'm going to copy 018 over to 019. And we'll just call this pointer stuff and drop down into 019. And the Frankenstein text, I should just move that up into a documents folder, but that Frankenstein text is, just a piece of data that I was using in the previous video. I don't need that. I'm going to drop into source demo. I am going to get rid of all of that and all of that. Oops, I don't need that. We'll run that. No, we won't. Apparently I didn't complete that line. Then we'll run that. Okay, so we have a working empty program. Okay, I'm going to end up looking some stuff up here, I'm sure, but we can start. Obviously, what does a character literal look like? You almost never use it. So in like, what I want to do is, essentially that. Is that right? Copilot just suggested it, so it could be right. Put car P to standard out. Does that run? Let's give the simpler version, which is void main too many arguments for the function put car. Okay, so let's put C is probably what I want. It takes put C, writes a character, cast to an unsigned character to stream. Put C is equivalent to F put C. So F put C except F put C. F put C int C file stream. Okay, so put C and did I put C? Int. So it is just int C. So by equivalent, they literally mean equivalent, and then here it just takes the int. So if I Looks like I introduced an error in my make file. So what was the command? Amake. Oh, it must be in my vimrc file. So I don't get what's going on here. So if I try to run it, I am getting amake. I do not have amake anywhere in here. So it must be in the make file. Let's go to run. Bin name. Okay, make run. On line 40. What? Make clean. Make. I'm still confused by that A. Make run. So somewhere, so what make does is, let's look at it. What make run does is it first clears the screen and then it run. Oh, that A is the character we're outputting. Jesus. I can't believe I just confused myself with that. Okay, so here is, okay, so that's horrible. I don't know why we're calling it P. We're going to call it C because it is a character, and then we're going to output C, right? So that we have a literal character. So, right, obviously, if we want to have a pointer to a character, right, we can take the address of C. So what I don't know. I'm going to look this up in a second. What Chrome is what I want. Printf print format address. How to print a memory address in C, and what I want is printf. And what they're suggesting here is the address is %p. So %p. I shouldn't. I might have to change that to a void. Let's take a look. So it's a void pointer. So they're suggesting that the right way to do it there is void pointer. And what I'm going to do is this puts add a yeah, it does. Right. So I'm just going to do that to separate that one. So we output the character. We also output the new line here. We just bake the new line in. Does this need to be there to compile without error? No. And it would seem to me that it shouldn't, because let's take a look here. Why do they say the standard requires that the argument is of type void pointer for the P specifier? The printf is a variable function, so there's no implicit conversion from. Okay, so void pointer should be there because I don't have a void pointer up there. Now P is a character pointer. I made it a void pointer. So let's do this. let's say, hey, what's the address of C? We should all be the same, right? We are. Okay, now the thing I want to get to is a character pointer, PP, equals the address, P. And why is with this P thing? Oh, because it's a pointer. And this is a pointer to a pointer. Okay, so I get the naming. This is Copilot suggesting names that weren't in my head, so I had to think it through there for a second. Okay, now the thing I'm trying to understand is, well, so we're getting the same address for all three, right? Well, that was because, there we go. So the first one is the same because we're saying, hey, give me the address of C. Here we're saying this, we've assigned the address of C to P, so that should be the same. And then this is a pointer to P. Now, how do I dereference that? How do I get back to the previous one, right? And that is exactly how to do it. So if I take a pointer to a pointer and simply, dereference it with the asterisk, the pointer operator, whatever it's called. Does that have a name? That's curious. Let's find out. Oh, it's going to be multiplication because I said operator. Let's try it this way. To declare a pointer, you use the asterisk for a pointer. This declares a pointer. Yeah, I know it to play, but I want to know if that operation that if it has a name. I don't know. I think it just is pointer and pointer of. Okay. I don't think it has a name. Maybe if I went and read the. Okay, so this implies to me right now that I did understand it, that I didn't have any issue, right? So we can take a character. Let's put these all out. So let's make sure I can reference them. So I should be able to put character dereference P and get the same value as I did in the first one. In fact, let's just do these right in a row. So if I just can't get used to this keyboard. So if I put that there, so we did this and we discovered that the addresses are let me take this one and put it up there too. So I can reference all the values the way I think I can reference all the values. I'm not confused. Let's run that. We get the A. Now let's go further. Let's go further one step and do the next one, right? And so to if I have PP, that is not a good name. Small things amuse. Oh God, that's even worse. Oh my God. I think that I have to dereference it one more time, and I don't know for sure how to do that, but I think that this will get us there. And it does, right? So I have 1, 2, and 3. Okay. That, but let's say that I want to overwrite the value C, right? What I would do then, so I'm going to, I can only do it with the 2-pointer ones, right? I can't So what I want to do is I want to say, hey, I want to make an assignment to P, which is just B. And then once I have that, right, I want to output it. Did I just change what is in C? Actually, let's do this for all of them. So let's, right. I should be able to show that by referencing, let's just run it. No. No, because what I have to do now is I have to do it that way. I need to, would I have to do this? Okay, that did not save. There we go. On 21, missing a semicolon, so I was probably missing that all along. Do I just... No. That's not right. I want to dereference the pointer. I'm making an assignment to that slot. And I have changed it to B, just as I expected to. Okay, so let's do similar, but I want to do it via PP. So given PP, I want to make it C, and then output them all out again. So I think the thing I have to do is basically the exact same thing I did below, which is that A, B, and C. Yep. Okay. So if I want to change the literal contents, I have to make the assignment dereferenced. Okay. I seem to fully understand this. But I get the feeling when I go back and try to do the work to work on the code that I couldn't make work before, I'm going to have problems. Okay, I'm just going to walk through this just in case somebody ever comes along and looks at this video, and since it's such a short one. What I got going on here, of course, is I create a character literal that has the value A. I create a character pointer, which I set to have the address of that character to literal. I have a pointer to a pointer, which ends up being the address of P, which is a pointer. Okay, print all of those out, referencing them to get, or print out all the addresses of those. I get what I expect when I print out the addresses. That is the address of the character literal. Actually, let's write what it's. So this is the address of C. This is the void pointer cast of P, and then let's line these up. And then this is the void pointer of PP, and it'll just make it a little more clear if I'm ever looking at this in the future. This is the void pointer of star PP. Right. So the address of the character is this. I've assigned the address of the character to the point to P, and so P is the same thing. It's a pointer to that thing. Now, PP is holding the address of P, which is that. And if I dereference PP, I can get back to just thinking this through real quick. So this is the literal. I take its address. Of course, I get that location. I assigned that address to P. So if I just print out P, it says, hey, that's the address. And what I'm missing here is I want to right, so that assigns the address. This is a pointer to that address. It will have a different place in memory. It does. But if I dereference it once, I get back to that same place in memory. And when I am actually outputting, so that's kind of what I'm missing here is, right? So if I want to output P, I just have to dereference it, and if I want to output PP, I have to dereference it twice. I don't know. I completely get it. I don't know what I was getting wrong in the other one. So we'll leave it at this, and go back to the previous project, and then just work out the problems. Probably have to do a little bit of puts debugging here, so I can like print the addresses and see what I'm messing up in the other one. I was having a hard time doing that in the debugger. I do need to just spend more time with GDB. But that will be all for this video. I'll pick up trying to sort out my mistake in the other in the next video.